Hi guys. So we're starting off with 13.2 absolute value functions and transformations. Now, we're going to go ahead and start off talking about what absolute values are and the relationship between input and outputs, and then the definition of the absolute value itself. And so let's look at the first conversation piece. Now, on the following graph, using different colors, we're going to graph f of x and g of x. So f of x, I'll go ahead and use red. Okay, and basically, again, f of x is equaling to x. So my initial value is 0. Okay, my b. And I'm thinking about y equals mx plus b, basically. But my slope is 1 because my coefficient in front of that x is just 1x. It's 1. So I go up 1 over 1, right? Up 1 over 1, up 1 over 1, up 1 over 1. And then we draw our line. And we all remember that from 8th grade. We remember that from even uh, in high school. Okay, so there's f of x. Tried my best. All right, so g of x, on the other hand, equals negative x. So let's go ahead and graph him in green. So again, our b, our initial value is 0 because there's no number adding or subtracting to the negative x. But our slope, on the other hand, our rate of change, well, it's a negative 1x, right? Negative 1. So we go, instead of up 1 over 1, it's down 1 over 1. Okay, down 1 over 1, down 1 over 1. Okay, so again, let's think of it like this. And let me change a different color here instead of green. No, I'll just stick to green. Okay. So hopefully you guys can see it. And again, we'll just connect the dots. And that starts to give us a sense of the direction our line is going. All right. So that's just a discipline back from 8th grade, followed through with high school. Okay. Again, that was g of x. All right. So an absolute value of a number is its distance. So especially in geometry, we cover this at great length. In fact, I just did a video, I believe, discussing distance with scale factors and all that good stuff. But distance can never be negative. Okay, you could have zero distance with an object or a certain amount of distance. There's no such thing as negative distance. And that's what absolute values really kind of emphasize. There's no such thing as negative for absolutes. It's got to be, something positive or zero. This means no matter what input, okay, of an absolute value, the output will always be positive. Okay, so if you plug in, you know, -3 for f of x, and that's a, you know, equaling absolute value of x, you should get a positive 3. Okay, you will not get a negative after you plug in that -3. Okay, so you plug in the -3 to the absolute, it's not -3, it's positive 3. Okay, you can't get a negative coming out. All right. All right, so let's see. On the graph above, we're going to highlight all the positive outputs of f of x equaling, yeah, so f of x and g of x. All right, so positive outputs. Outputs usually mean f of x or the y values. Okay, so let me get the highlighter here. Or how about this? I'm just going, actually, you know what? Yeah, I'm going to do that. Let's see, where's the highlighter when you want it? There we go. There's a highlighter. I'm going to pick a awesome color. Ooh, does that? Yeah, that's a pink. Ooh, right, pink. All right, so I'm going to try highlighting this, and hopefully it doesn't do anything weird. Um, all the positive values. Ooh, I do not. What is it doing? What if I did that? Oh, I see what it does. That's not good. Okay, so I'm going to still try to highlight, but basically all the positive. Okay, get out of there. Come on. Oh, I don't want that. So you notice in that area, actually, that's kind of cool. That's spiffy. I like that. Notice in this area for the line, all the outputs are positive. You have 1, you have 2, you have 3, you have 4. They're all positive, and I'm going to ignore, this part, right? We're going to ignore that. So ignore that because you have -1. That's negative. We don't want these. Okay. So I'm just focused on what's there in the highlighted region. Okay, those are my outputs that are positive. Okay. Now, if you look on for f of x, okay, so it looks like I just looked at g of x as outputs. If we went ahead and looked at all the values that were positive for f of x, it'd be this part up here as well. Okay, because again, your outputs, your y values, are all positive. Okay, 1, 2, 3, 4, etc. These are all positive. Okay. Now, if you just look at, so let's see, for what values of x is f of x positive? Okay, so f of x was the red one. If we plugged in 1, we got a positive output at 1, right? So x equals, 1. Um, 2, right? We get a positive output there. 3, positive. 4, positive. 5, positive. We all get positive outputs in that region, right? So what values of x is when f of x is positive is basically when or if your input is uh, basically greater or equal to 0. Okay, that occurs. Now for g of x being positive, if we look here, we already talked about 0 for f of x, but if you notice all your inputs, if you plug in -1 for g of x, you get a positive, right? +1. You plug in a -2, you get a +2. Plug in a -3, and out comes a +3, right? Plug in -4, out comes a +4, right? So it looks like if x is less than 0, you get a whole bunch of positive numbers, okay? And if you notice, if you were to connect, and let me draw, let me choose this ugly orange color, okay? If I was to connect the positive outputs of this, it forms like a V-shaped, right? This is what we call an absolute value function, okay? It looks like a V because all your outputs are absolute. They have to be positive in those situations. For when you plug in something, it has to become positive. So let's look at the definition because this is what's leading it into. So in mathematics, the absolute value of x is known as, absolute value of x, that box. Okay, so you guys see this, you got to think, okay, if I plug in any number, out comes a positive. All right. So based upon the graph, the intervals that we just did, we know that we could define f of x equaling the absolute value of x, all right, to be this. Here's f of x equaling x, and it equals two situations, okay? And one we saw in f of x, right, where the values were greater than or equal to 0, or that situation with g of x where all your positive outputs were when x was less than 0. Okay, so again, everything in that pink right there is basically saying it this way with that. Okay, so this is the actual definition. This is just the result on a graph. Okay, so that V, that yellow V right there. All right, so take your time. It's a lot to take in. It does get easier, I promise. All right, and we're going to talk about some familiar things for right now. So we're going to go into the conversation of domain. Now remember, domain is your inputs, the x values. All right, so what is our domain? If you looked at our values here, we use all kinds of input values. So let me go ahead, and I'm going to go ahead and erase um, most of this mess down here. Okay, there we go. And if we look, let me go ahead and See if I can delete. There we go. Yeah, I'll do that too. Ooh, that's nice. That's nice. Okay. Now again, domain is all our x values. Now, remember we did use lines, and lines are continuous. Let me use this dark purple. Our domain, we used all real numbers. Okay, we used 0, we used 1, 2, 3, 4, 5. We used -1. So basically, all real numbers. Okay. Some people will actually do, you know, basically you have negative x, or I'm sorry, x is greater than or equal to negative infinity, or less than or equal to positive infinity. Okay, they say that sometimes. Actually, let me rewrite it to where it's more commonly visible. It still means the same thing, but I'm just going to rewrite it for you guys to make sure you guys don't get tripped up if you see it written any other way. So you got x is um, less than or equal to positive infinity, or greater than or equal to negative infinity. Okay, so basically just all those numbers. All right. Now the range, remember range is output. Now, do you guys notice on the outputs, you start at 0 and then you just go all the way up to infinity for your outputs? You don't exist down here for this absolute value. Okay, because they didn't have positive outputs. Okay, so there's nothing for outputs when you go past 0. Okay, so actually in geometry, or not geometry, in calculus, pre-calc, even algebra 2, some people start doing this whole bracket thing, and then they just draw an arrow, and that basically says, like, we stop at 0 and then we go up to infinity. So basically our range is this. It's y is less than or equal to infinity, okay, but it's greater or equal to 0. Okay, so basically it's like saying you could be at 0, but you can only go up. You can only go up to infinity. All right, and that's basically what it's saying. That's why we don't have anything down here. All right, because we were looking for positive outputs only. Now, increasing on the interval. So if we think about it, if you look at from 0, let me clean this mess up as much as I can because it got messy real fast. All right, can I? Oh no, I deleted that. I didn't want that. All right. So, whoa, whoa, it's getting a little too happy here with the eraser. And there's no undo button. Great. All right, so there we go. Quick little fix. I'm just trying to clean it up um, so you guys understand what we're looking at. Let me get rid of these symbols. All right. Don't get me wrong. You're going to see plenty of other examples of where this gets cleaner and less confusing. All right. So let's see. I'm going to use that ugly color. Yeah, ugly color. All right. So we got this V, right? And we have all these positive um, outputs, right? And we carry this V because of this situation. Now, if you notice, the interval that's increasing. So which side? All right. So again, we had g of x and f of x. Which one had a positive slope? Was it f of x or g of x? Okay. It was f of x, right? We were going up, up, and away. And f of x really started here at 0, right? So from 0 to infinity, we had a positive slope. We were going up. Okay, so we were increasing. So the interval is basically from 0, and again, we're talking about x values. So when x is greater or equal to 0, or it's less than or equal to positive infinity, because it keeps going forever. All right. Now, if we talk about the decreasing on the interval, if we notice on the other side for g of x had the negative slope, remember? So it is actually decreasing on that interval. What interval is that? Basically anything that's less than 0. So again, x is going to be less than 0, but it's also going to be greater or equal to negative infinity. All right, so everything on the left here is decreasing. Okay, it's going down. But on the right of 0, including 0, okay, so on the right, we're increasing. And again, that's because on this side, it's positive. All right, so that's what they're talking about with the intervals. All right, one side's going down while one side is going up. All right, that's the idea. All right, so in behavior, so the graph, all right, so this is actually a next conversation piece that you guys really need to pick up in behavior. Okay, you're going to hear this a lot. The graph blank to the left. Okay, so if you look on the left side um, of the graph, this actually rises, goes up. So as you approach this way, okay, the graph goes upwards. All right, that's what we say. So we rises to the left. Now we're not talking about decreasing in the sense of slope. We're talking about which direction does that line, or more specifically that ray, uh, go towards. So it actually rises to the left. So rises to the left, and it also rises to the right. Okay, so as you go to the right, it also goes up. Okay, it's going up that way, and it's going up that way. Okay, so as you go to the left, you're going up. As you go to the right, it's going up. Okay, and that's basically what we're talking about within behavior. So the vertex of an absolute function is the highest or lowest point of the graph. Okay, so if you look here at our v, where's the lowest point? What coordinate is that? That is at 0, comma 0, the origin, right? So our vertex happens to be at the origin, 0, comma 0. All right, and this is super important. All right, and we're gonna get more practice and we're gonna get a little bit more comfortable with this conversation. And yeah, based off the definition, whenever mathematicians go into the definition, what we're basically saying is brace yourself. We're going to get really, really in depth, and it's probably going to confuse you a little bit. But let me show you how we approach it in solving with graphing more specifically for right now. And you're going to find out this isn't as bad as it's made out to be. All right. So give this time to soak in, ask some questions right now, and let's get a conversation. So right now, let's actually ask some questions, and it's okay if you have that headache. It's fine. It's normal. All right. So hopefully we had that conversation, and let's kind of continue with some tables. All right, because we've seen tables before. Now the parent function is this guy. So remember the rule. Okay, it's the absolute value of x. So if you plug in the absolute value of -1, we can't have that. Okay, so what's supposed to come out of that? +1. Okay, throw in a 0. What's the absolute value of 0? That's just 0. 0 can get away with that. Um, what's the absolute value of a +1? A +1. Okay, notice how the -1 had to change. All right, it had to change. All right. Everybody, we do things, especially when we grow up with responsibilities, we change. Okay. There's people that we care about. There's some people you just can't be negative around. All right. You have to be positive with them. Um, that's kind of like the rule here. All right. You have to be positive. You can't be a negative Nancy. All right. So here we go. Uh, First graph. So here's our first example. We got g of x equaling the absolute value of x plus 2. All right. So let's use the rule. First things first, I want to pick some coordinates. All right. I want to pick, let's see, I'm going to pick -2, -1, 0, 1, and 2. Now, eventually, you're going to learn how to pick your own input points. But for now, I just want you to know to trust me. I kind of know what's going on here with the numbers and the inputs, and eventually you're going to figure out how to get your input values using the vertex. Okay. So real quick, let me explain. All right. So the rule again. So we have the absolute value of -2. We're plugging it in for x plus 2. All right. Now we can't have the -2. So the absolute value of -2 is positive 2. And now what's 2 plus that other 2? 4. Okay. So we have -2 comma 4 right there. All right. And let me zoom in because I'm starting to feel like maybe I should zoom in just a little bit more. There we go. All right. All right. So let me move on to -1. So absolute value of -1 plus that 2, just like the original equation. Now we can't have a -1, it's got to be positive, right? Right. So an absolute value of -1, positive 1. And don't forget that plus 2, and 1 plus 2 again equals 3. So we have -1 comma 3. Sweet. And now 0. Absolute value of 0 is just 0, right? Good to know. And 0 plus 2, right, is 2. Sweet. And 1. Absolute value of 1 is just 1. Plus 2 was 3, right? So we got 1 comma 3. Now, you can actually figure it out. We already got a V-shaped, right? So remember, we're still going to get a V-shaped graph. Absolute values are V-shaped, okay? So it should have this pattern of where you get this V. So I got 2 comma 4. You can double check. Absolute value of 2 plus 2. Well, absolute value of 2 is just 2, and 2 plus 2 is 4. Okay, so 2 comma 4, that checks out. And as you can see, we get a V shape. All right, that's g of x. And as you can see, my straight lines are getting worse the further I get on a touchpad. All right, so that's g of x. Now, our parent function, remember, let me graph it for you. Starts at 0 comma 0 with its vertex. Goes up 1 over 1, up 1 over 1, right? F of x equals x. And then g of x was negative x. So it was going down 1 over 1, right? So again, this was f of x. That's your parent function. Now, what's interesting is if you look at the parent function, which is just f of x equaling the absolute value of x, the only difference from f of x to g of x here is that plus 2. So what does that plus 2 do? That plus 2 moves your vertex, okay, up 2 units. It just shifted it up, okay? So the output values all increased by 2, okay? So if you were to graph the parent function, you would notice its outputs, okay? Its outputs would have just been 2, 1, 0, 1, 2. But if you notice, this plus 2 here increases the outputs of f of x by 2. Okay, and that's always kind of an interesting thing to note about the effects of constant terms that are adding or subtracting. They can do that. Okay, they can move up your v or move it down. Okay, so be aware of that. So speaking of which, if you notice, we have this minus 2. So is that going to increase our outputs by 2 or decrease? All right, so let's use the same rule. Let's pick the same coordinates, -2, -1, 0, 1, and 2. So again, absolute value of -2, can't have that, it's positive 2, right? But what's 2 minus 2, right? 0. Absolute value of -1 should be positive 1, and 1 minus 2 is -1. So as you can see, it does change your outputs. 0, absolute value of 0 is just 0, right? So you're just starting to see the input and outputs. So we get 0 minus 2, that's -2, and absolute value of 1 is 1 minus 2, which again is -1, and I think we get 0 there because if you do the absolute value of 2 minus 2, it's really just 2 minus 2, which is 0. Do you guys see the symmetry that occurs on the table? There's actually symmetry here. Okay, even with the outputs on graphs, you can see it in the last examples, there's symmetry. Okay, 3 with 3, 4 with the 4, 1 with the 1, 2 with the 2, and they all happen over the vertex. Okay, in the last example, our vertex was at 0, comma 0 for f of x, and it was at 0, comma 2 for g of x. Okay, so that symmetry occurs right at the vertex. It's kind of interesting, and in fact, we get into it a lot with geometry, and that's when we start talking about symmetry and reflections. All right, so let's go ahead and graph this. Originally we had negative 2, comma 0. So negative 2, comma 0 is uh, right here. 0. Huh. Okay. Yeah, sorry, I had a little moment. It's the first video I did in 3 weeks, so I'm kind of out of it. Negative 1, comma negative 1, it's right here. 0, comma negative 2, right here. And 1, comma negative 1, right there. And 2, comma 0, right here. So if you notice, your coordinates all make this V pattern, like ducks. The mighty ducks. Emilio! All right, so there we go. And here comes the difficult part of drawing that straight line as I go to the left on my touchpad, which always seems to be the difficult part. All right, there we go. So as you can see, we have our v. Now, if we compared it to our parent function, so let me go ahead and graph the parent function, good old f of x. Okay, we start at 0, comma 0, go up 1 over 1, right? And then start at 0, 0, and then go left up 1 over 1. Okay. Of course, we're going backwards, so technically it's down 1 over 1. But if you notice that v, what changed? All right, our vertex was at 0, comma 0, but now it's at 0, comma negative 2. It decreased by 2, it went down 2. And that's the effect that this term has right there. Okay, that minus 2 just shifts all the outputs. It decreases the outputs by 2. All right, so originally for f of x, we were supposed to be at, let's see, negative 2 was positive 2, but it decreases by 2. 1, or negative 1, comma 1, but it decreases by 2. 0, comma 0, but it decreases by 2, so 0, comma 2, decrease by 2, decrease by 2. And that happens with all the, the points, okay? It shifts everything down. All right, so let's take a look at some other examples. Let's see, how did the inputs change from the parent function? So let's say this, if uh, g of x equaled the absolute value of x plus some value, okay, k, okay, um, comma, then the outputs increased, right? The whole function, especially if you graphed it, they would shift up, they would go up, right? So they would increase by whatever that number was, by k, okay? If it was 2, it goes up by 2. If it goes up by plus 10, it goes up all by 10, right? Now, if g of x equal the absolute value of x, but minus some k value, then the outputs decrease, all right? They go down. We're going down, down by a certain value of k. Sugar, we're going out. Graphing. All right, there we go. All right, so we already kind of saw that, right, in the tables. Good to know, good to know. Now, how did the outputs change from the parent function? Um, oops. You guys see my mistake? They're talking about inputs here, silly Mr. Webb. So everything that I just wrote here is actually the answer for this question. So again, the inputs, they did not change. They did not change. If you look at our x values, I'm still using -2, -1, 0, 1, 2, right? The -2 didn't make me change my mind on that. Um, Still same thing here. The +2 didn't change my mind on what inputs I wanted. Even if, so it didn't change what I wanted to use for my inputs. I still use the same inputs. It didn't change that. But my outputs, okay, big change. So inputs did not change, but everything I just said earlier, that's in regards to my outputs. Okay, so please note that. That is the actual answer for the next question. Now, how did the graph shift? So, number one, okay, we actually shifted up by 2. We went up. Okay, so f of x, the parent function, really just moved up to g of x by 2. If you look at number 2, we went down 2, right? So here's the f of x, and then we just went down 2 spaces for g of x. Okay, that's what happened there. So again, number 1 shifted vertically. Okay, that's up and down by 2 units. Uh, More specifically, shifted up vertically. Let's get a little more detailed there. So we shifted up vertically by 2 units. And number 2, we shifted down vertically by 2 units. Okay, so those were the two differences. We still went up or down, right? So that's something to note about what that value does on the outside of our absolute, okay? That plus or minus some number, okay? So those are the first two transformations that can occur. All right, it looks like we're going on to the next set of transformations. And we're going to go ahead and practice real quick. I'm going to give you a problem to graph um, for one of these. Okay, so I'm going to give you an example and I want you guys to graph it. Okay, so we're going to try that first. Okay, so hopefully you did that. Number 3, g of x equals x plus 2. So we're going to use the table first. And again, I'm going to still pick the same values, and hopefully that doesn't mess us up. So let's try -2, -1, 0, 1, and 2. Now, real quick, I know it's going to have some problems, and I'm going to explain to you why that is. But let's go ahead and pretend we don't know, okay? So, because I know you guys are probably new to this, so don't worry. Um, Absolute value, okay, of x plus 2. X is -2, so we're going to substitute, right? We're going to plug in that -2 for x plus 2. -2 plus 2 is 0, and we know that the absolute value of 0 equals 0. Okay, that's good. That gives us a point. So let me make that in red. -2 comma 0 is right here. Okay, that's interesting. And then -1. Okay, so let's substitute it in. -1 plus 2. Okay, -1 plus 2 is the same as saying 2 minus 1, which is just 1. And the absolute value of 1 is just 1. So we have -1 comma 1. Whoa, we're going up already. Interesting. Now 0. 0. So if we try this, you'd realize that 0 plus 2 is just 2, and absolute value of 2 is just 2. Notice that we keep on going up, right? And if you were to do this the first time, you'd probably be like, where's my downs? I just see I'm going up, but where am I going down? I don't see a V. I'm not seeing the Mighty Ducks here. Okay, you'd probably be freaking out. Don't worry, we'll get to that. So absolute value of 1 plus 2, which is 3. Absolute value of 3 is just 3. And look at that, you're not even seeing symmetry yet. And we can go ahead and predict that absolute value of 2 plus 2 is 4. And the absolute value of 4 is, again, just 4. Okay. There's no symmetry either. You're just getting a straight line. And you're like, Mr. Webb, where's my v? Okay, so check this out. This plus 2 actually changes our inputs. Okay, it changes which inputs I should probably pick. Okay, so now I want to kind of teach you the idea here of how to find your vector first because I'm sorry, not your vector, your vertex. Your vertex is one of the most important things to find first. Okay, it's one of the most important things. All right, so let me ask you a question. What number can I plug in for x to where I get a 0 inside? It's -2, right? So, because we just found it right here, right? So instead of picking 0 as my middle number, maybe I should have picked -2 because my vertex is at -2 comma 0. That means if I picked -2 at the beginning, okay, and let me go ahead and create a table off to the side, all right? If I pick -2, because again, what number can I plug in here to get a 0? It would be the opposite of a +2, it'd be -2, right? So I pick -2, and then I start picking numbers to the right of -2 and to the left of -2. All right. That would probably actually be more strategic, especially for tables and for graphing. Okay. And eventually we'll just focus on the graphing aspect, but I kind of want you to be aware that that +2 inside your absolutes, it changes your inputs. Okay, it changes the x values you should probably use. Okay, so just be aware of that. Now, if you end up doing the table for -4 and -3, you basically just realize that now you get your ducks on your other side, right? The duck formation, and then you got the flying V. Emilio. All right, that's a terrible straight line, I know. But basically, look what happened, okay? It's no longer at 0 comma 0, okay, like your parent function. Your parent function, again, I'll call it f of x, was here. But what changed in your graph, all right, from f of x to g of x? What changed? Okay. What changed in the sense of your vertex? Your vertex used to be at 0 comma 0 for your parent, but how many places did it move and what direction? Okay, so can somebody answer that? Let's talk about it. All right, so hopefully we talked about that. And now we see this guy, -2. All right, so, ooh, it's probably going to change our inputs again, but it's a -2. Well, the last one was a +2. So the +2, it moved us to the left 2 units, right? It shifted us horizontally um, to the left 2 units. That's interesting. So if +2 is to the left 2, what's a -2? Okay, so let's go ahead and figure this out. What's the opposite of a -2? A +2, right? Now let me pick some numbers that are to the left of 2. Okay, so that'd be 1 and 0. And to the right of 2 would be 3 and 4. Okay, so I'm thinking of like the domains. Okay, my x-axes. Let's go ahead and plug in our inputs. 0 minus 2 is -2, and the absolute value of -2 is +2, so we have 0 comma 2. All right, and then we have 1 minus 2, right? I'm plugging in that 1 for x, which is -1. The absolute value of -1 is 1, so we have 1 comma 1. And then 2 minus 2 is 0, and we all know the absolute value of 0 is 0. Very nice. And then 3 comma, and also be aware we picked 2 because, what's the opposite of -2? We're actually talking about our vertex right there. Okay, that's like the methodology of actually identifying your vertex, which should be, again, one of the first things you should do when you're graphing right away. Okay. Um, 3, plug in 3 for x, and get an absolute value of 1, which is 1. And also you start to see the symmetry again. So if that was 1, copying to that one, What should this guy be? 2, right? Symmetry. So let's try that idea out, make sure we're not making up some craziness. Absolute value of 2 is 2 because 4 minus 2, right? Okay, so we got some new coordinates, 3 comma 1 and 4 comma 2. We got our flying V. There we go. I'm going to try going down and towards the vertex. That's still terrible. It's supposed to be a straight line. There we go. All right, now that was for g of x. Now what did the minus 2 do? Okay, our parent function again was supposed to be at 0 comma 0, right? What changed? Which direction did g of x move? All right. If you look at the vertex, we were supposed to be at 0 comma 0, but now we're over here. All right. How many spaces and what direction did we move? All right. So let's talk about that real quick. So, what effect did that have on our x values, on our inputs? All right. So, some real quick questions. How did the inputs change from the parent function? Okay, so here we actually did experience a change. If g of x equaled x plus some number, okay, then what? Then our inputs, okay, we shifted to the left 2, right? So if we shifted to the left 2, our inputs would decrease. They go down by 2. So then our inputs increase the distance really. But basically, the inputs shift left, so they decrease by k, whatever the k value is. If g of x equaled x minus k, on the other hand, right, then our inputs increased by k. So that's why I changed my numbers. Instead of picking -2, -1, 0, 1, 2, I actually had to make some changes, right? So that's what they're talking about with inputs and outputs, or more specifically, inputs. Sorry, we're focusing on inputs right now. Um, but graphically, right, this situation would actually shift us left, right? So we shift horizontally left, and we'll get to that. Here we go right, okay? We shift to the right. So how did the outputs change? They don't. They don't. The outputs don't change. Okay, and you could see that with the vertex. Okay, the vertex, like here's your parent, uh, here's your g of x, right? But the vertex is still at the same height. It didn't go up. It just shifted to the left. All right, that's like what I'm talking about. So the inputs changed, the x values changed, but not the outputs. All right. So how the graphs shift? This is number 3. All right. So if you look at number 3 again, we went 2 units to the left. So number 3, comma, we shifted g of x 2 units to the left. And that was, again, horizontally. Okay, so we went that way. Number 4, we shifted g of x 2 units to the right. And again, that was horizontally. I know when I was a kid, I didn't really use those words a lot, vertical, horizontal. But I got to tell you, those are some good words to be aware of. I know culturally, especially where I came from, I didn't use those words a lot, even though I had a math teacher for a dad. But it was one of those things where I just didn't use it a lot in my daily language. So just be aware of horizon, right, left or right, horizontal, vertical, up or down. Okay. You will see that in CASP and other future tests or SATs. Okay, so for now, um, that's all we're going to cover, and I'm going to give you a couple problems for your homework, and then we're going to cover this concept on day 2. Okay, so for now, go ahead and stop with the notes, and I want you to have a good day. Um, and again, if you have any questions, come see me. For now, just try to determine, do I go up or down? Do I go left or right? And eventually we're going to get that conversation going for you guys, and we'll get some more practice. All right, guys, thank you. Have a good day.